Alrighty then. Hello? 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 Look, she's not even paying attention. She's staring at her phone, didn't she?
I am paying attention. You're wrong.
Did you say hello?
I did not say hello.
Exactly.
I do not want to say hello.
Okay.
I said it twice.
Haha,
Not
just got you
that
say it.
hello.
Just got you say it. Alright, so fundamental theory of calculus. So now,
Fine. I'm just kidding.
fundamental theory of calculus means that these things right here are going to be hold true for all parts of calculus. Okay? Fundamental theory. So we actually get all kinds of other math just by using this theory. So it's kind of like gravity. Gravity is always true, right?
No.
Why they didn't learn it from the beginning then if it's fundamental?
I'm sorry, you're mumbling. I'm not even listening anymore. Okay, so it's like gravity. Gravity is always in all equations, and we actually use math and other things to manipulate or to be able to incorporate that into my other math. The equations of my, dropping a ball on someone's head that's not paying attention, or other things like that. Velocity, speed, okay, acceleration, those type of things. But this always works. So we use this to actually do a whole lot of interesting stuff with our math. All right, so let f be a function that is continuous on a closed interval from a to b. The function I is defined by, okay, from a to x, and it's f of t dt. 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 So what does that mean? In terms of t, right? In this case, it would be, we would say time, right? So now, when we're taking this is the integral, right? But if we're taking the derivative, which is I prime, right? I prime, so the derivative of the integral, it should be top minus the bottom, where it's actually just going to be the f of x after I'm done.
What?
Where'd the x come from?
Is it like the second point?
Right there. The top, right?
It's like the second point.
Yes, it's the end point on this.
So we get the function of the end point.
But it has to be from there. If I'm taking the derivative of the integral, and it looks like this. For all x in the interval from a to b. So, use this, we're going to actually show how this works. So we're taking the derivative of the integral.
Yeah.
The derivative of the integral. So we're plugging it in for what we have here. So this goes into my function in place of t.
Okay. And then we have to find the derivative of this.
Okay? No, that is the derivative of the integral. Remember, integral is the antiderivative.
Yeah.
Okay, go ahead.
Excuse me?
Was that a question?
No.
No, your hand was up, so okay, sorry.
Wait, so wait. But you're just plugging in x instead of
From the top, if I'm taking the derivative of the integral,
yeah.
But why do we need to take a derivative?
the derivative of the integral, because a lot of times you're going to actually have equations that give you more equations. So you're never really going to always solve for just some number, some numerical value here. You're sometimes going to be solving for other functions to use that function later on.
Yeah, but
Math is not always about getting a number like the number 5. Sometimes your answer could be x squared minus 3.
yeah, I get it. But
That's what we're doing here. So we're trying to get to there to get from something else.
I just don't get it why like the finding derivative from the integral is just plugging in x instead of actual arguments.
Because this is the fundamental theory of calculus.
So
It's no explanation.
it's like so it's not derivative. It's just we just change to x. That's it.
No,
So I equals 1, right?
Yeah.
Oh, yeah.
So we're canceling out. Okay, so watch this. If I have a square root of x squared,
Yes. Okay. It's gonna be x.
why?
The square root squared is gonna be x.
It will cancel out the 1, right? It'll cancel, one cancels out the other.
Yeah.
So the derivative and the antiderivative together should
Cancel each other, yeah.
cancel each other out.
Okay.
So same thing goes here. Of my x cubed minus 1, then it's 2x plus x plus 1, right? Okay, so now, this right here.
Oh.
What would I do for this one?
Instead, like it's gonna be square root of e to the 2 power.
Okay, so it should come up, so it should be like this, right?
Yeah.
So it's going to become the square root of, because these are x's, right?
Yes.
The derivative in terms of x of the function that it is in terms of t.
Mm-hmm.
So this goes in here. So it's going to be e to the 3x squared plus 1, right?
3
Plus 3x squared plus 1, right?
That's it. I guess.
Make sense or no? Or I'm still losing you guys. I lost you? Okay, because she's over there drawing on your desk.
I'm not drawing. I'm like writing the notes for her and the thing.
You're writing the notes for her?
On her paper.
Okay. Isn't that so nice of you?
Yes, you failed to see it.
I know.
No, she's my teacher, low key.
She's the low-key teacher?
Yeah.
Okay. All right, is there any questions from this or no?
I still didn't get it where we're gonna use it.
All right,
I need an example.
there's one more issue I have here. Okay, because of this, right here, we were just plugging in these right here, right?
Mm-hmm.
Okay, because we just plug in as that, right? But what are we taking here?
Derivative.
Derivative. But since I have this function up here, okay, what's the derivative of x? 1, right? Okay, so now I still have to take care of this last part here. What's the derivative of what I have here? So this is going to be times 6x. That's the only thing I'm missing. That's the only thing. Okay, just the derivative of what I'm plugging in. Because it said the derivative just going in, right? But it's the derivative of that item times my function. Where'd I get 6?
Yeah.
Okay, we didn't do the u's yet, and so I know I don't want to confuse you more with this because we're going to say that u is equal to 3x squared plus 1. Okay? Say yes.
Yeah.
Okay, good. So we're going to say that that's that. So when I go through and plug in, I'm going to have a du. Take the derivative of u, it's giving me du. Okay? And then when I take the derivative of this, it's going to give me 6x and then dx because that's the derivative in terms of x. I know this is probably a little bit more complicated than what we've done so far, but you wanted the explanation of why. So the next piece. So when I do this, it's going to be the square root e to the u, right? Plus u, which whatever my u is. Okay, and that's going to be du, right? But to get my du, okay, to get my du, I now have to put and then when I put that over here, it's going to turn into 1 over 6x. But then I don't like x's. I don't like x's. I don't.
Why?
Because I'm changing everything to u's, right? All my x's should be u's.
So we'll just rewrite it.
It's yes, but when it's times the derivative of whatever I had out here.
So then,
You know, I think I'm probably just going to confuse you more.
yes.
Okay, how about this? Let's just change it to this. Okay. Derivative of that
6x
times. Plug it in.
e to the 3x squared plus 1.
You're
Yeah,
gonna
we
add the
forgot
plus
plus one.
one.
It's
I'm
important.
sorry, my pen's running out of ink. Okay, is that easier? Let's just go with it like that.
Yeah, it's like it's just
It is.
yeah. It is.
Because if I try to go too much into it, like when I did the warm up today,
Yeah, but what am I
because
talking
there was
about?
like 3 different things that I haven't taught to you that I had to use to even do it,
So I
But the
need to
warm-up
get
is
that
fine.
one up
huh? Because you can do it using estimations, right? You were able to do it using estimations. You can't do it using regular integration techniques yet. So,
Yeah.
anyway, all right. Now let's take a look at what we got here. Let's take a look at what we got here.
Yes.
What's wrong with this problem? Besides that,
We just need to change the sign before.
I don't wanna do
To the
that.
x cubes on the bottom?
x cubes on the bottom. Thank you very much.
Yeah.
Now, how would I change to put my x cube on top?
Just negative before the
Yeah.
end.
It'd be a negative now, right?
Yes.
So it would be a negative. So I'm moving this up, so it's going to be negative d ddx integral from 5 to x cubed times t to the 4th plus 1 to the 1/3 dt. Okay, so now,
3x squared.
so what's the derivative of this?
3x squared.
So it's 3. So it's a negative 3x squared, right? Times
3. Oh, x to the 12th.
x to the 12th, right? So x to the 12th
Plus 1.
plus
1. 2 1
Is that easier now? No?
I mean, no, I mean, it's like easy, but I just don't understand why it works like this.
He needs the Y.
The questions that we'd be using. It's just the reason for fundamental theory of calculus, and this goes into actually founding other things using our bounds. It doesn't make sense, does it? Okay, it'll make sense later.
Just I don't
So
understand why
like for now.
derivative from antiderivative is just like
Why do you square a square root?
Because they tell you to.
Mathematically, sometimes you have to get rid of it, right?
Yes.
yeah. So
Taking the derivative of the antiderivative is going to get rid of that and just put the function back,
so
right?
why we were trying to find when we were trying to find areas under the graphs, why we just didn't take the derivatives from the antiderivatives, then we would get functions too.
But that would be just the function, it's not the area. It's asking for something different.
Yeah, but
Oh, each thing is actually like part of its own reason for each one of these. I understand what you're trying to say, but there is a reason mathematically. You have to sometimes undo what is done. So the x squared, to undo an x squared, you square root. Okay, sometimes we have to get rid of the integral by taking the derivative of the integral. I'm not trying to kill you with this or overdo it on you.
too late.
Huh? Too late.
You have to bring that picture. with
I
you.
know it's all theory. It's the fundamental theory of calculus. So this works of this, yes.
For now, we're just plugging it in and then taking the derivative, like even the homework question.
That's the first. That was the
Yeah,
first.
the
That's the
first
first fundamental theory of calculus.
Okay.
Okay, that's the basic fundamental theory of calculus. We're plugging stuff in, and then we're getting out whatever we have. Okay, so now right here, continuous on the closed interval from a to b. It'd be the integral of f of b, right? So we take the integral of the function, and if you notice, it goes from a lowercase f to a capital F.
That's what we did.
That's the terminology on this. So it's going from a lowercase f to a capital F. So a capital letter will signify that we have the integration of that. Just like if I put f prime would be the term or the notation of taking the derivative of f. Does that make sense now? So capital F is integration of b, so it's top minus the bottom.
That's what we did last time.
Yes. Okay, top minus the bottom. Okay, let's do this now. Using fundamental theory of calculus, we're going to do this one. So on this first one, we're taking the integration in terms of
X
x,
squared.
right? In terms of x. dx means it's in terms of x. It's possible to sometimes see something like this, that you're going to take the integral of 3t x dx.
Oh wow.
And so what would that mean? I'm taking the integral in what terms?
Times X.
X. So that means t is just going to be some constant.
Yeah.
Okay? We're going to treat it like it's some constant in there.
Okay.
It's not a variable in that sense. We're not taking the integration in those terms. We're just taking it in terms of the x's. Okay, so let's go ahead. Integration of x squared.
1 over 3 cubed.
So it's x cubed over 3 from negative 2
To 1.
to 1. Okay, so let's start off with the top minus the bottom. So fundamental theory of calculus. So it's going to be 1 over 3, right? Minus, so it's going to be
Over 3.
negative 8 over 3.
So it's just plus 8.
Negative 8 over 3. Does that make sense now? Or no?
This thing was
Didn't
making
we do
sense
this?
before. We did
We've done stuff like this, but this is
Yeah,
the
but-
theory behind what we're doing.
Just like so, like.
It's
in
top minus the
integral-
bottom.
So like in our integral we have so x squared is like antiderivative. It's not the function.
X squared?
Yes, because when we were finding derivative of the integral, we were saying that we have antiderivative inside. So x squared is antiderivative of something already.
No. No.
But-
Okay,
so
so you would take the integral of the velocity to get the position.
Yeah.
So it's not always going to be the first function that you have.
Okay. So then why we just? I don't know. We just.
Okay, so what is my answer here? What's the answer?
It's 3.
3. Right?
Yes.
Okay. Antiderivative of cosine.
Negative sign. No,
Why negative?
sign.
Just
Just
sign.
sign.
Just sine. So it's going to be a sine x from 0 pi over 6. So it's top minus bottom. So what is the sine at pi over 6? So what is sine at pi over 6? Don't you even try to put it in your calculator.
Sign.
So sine at pi over 6.
1
I'm
over
doing it,
2.
Pedro.
1 over 2. 1 over 2.
He says 1 over 2. He's the only person saying anything. Everyone else is just like nodding their head or copying someone else's notes.
I mean, I'm here.
Why
It's
would
the
you
sign
have
of the
this
30
one?
degrees, which is 1
Yeah.
over 2.
just making sure. Come on, you guys all need to be knowing these things.
But we don't.
For what? If you got into calculus.
Yes, no, maybe.
Yes, it's one of them.
Shh.
I don't know.
It's not always you. It's not always about you. I'm trying to ask other people a question, and you're just like talking over them.
Yeah.
Okay, it's not always about you.
Oppressed.
Okay, all right. So, do you guys understand unit circle or no?
Not really.
Not really.
Yeah.
Okay, so I'm going to show you guys a quick trick to the unit circle. Okay. So in the unit circle, I have. Okay, we know this one is going to be 1, 0, right?
Yes.
Okay. This one right here is going to be 0, 1, right? So halfway in between. So since this is calculus, we're always going to use everything in radian. So 90 degrees, same as saying pi over 2, right? And this one over here is pi over 4. So half of pi over 2 is pi over 4. All right? Halfway in between this and this is pi over 4. So next one down, here and here. So this one right here is going to be pi over 6 because it's half of pi over 3. So pi over 3, so this is 1, 2, and 3. So this would be 60 degrees, 120 degrees, and 180 degrees. Okay, so I'm going to show you the neat trick to go along with this. So as we're doing this, everything is going to be over 2. Everything's over 2. Okay? So, let's start from 0. Okay? So, from 0, that's the y values. So the y values are going this way, right? Okay, so now I'm counting in order. From 0, it goes 1, 2. So it's rad 2, and then rad 3. 1, 2, 3. And this one would actually technically be rad 4, but what is square root of 4? 2. So it would be 2 over 2, which gives me just 1 for this case right here. It's a neat trick when you're actually trying to figure these things out. And then now, since we went this way for the y's, we go the other way for the x's. So I started 0, so this is 1, this is 2, rad 2, and then rad 3. These always work, and it's the same pattern going all the way around. So it would be the same thing right here, but I know in quadrant 2, what happens in quadrant 2? X value is?
Negative.
Negative. X value is negative. So I would just make the x value negative. They're all the same. Just depends on what quadrant they are now. Is that a neat trick?
Yes.
Okay, so when you guys are taking the test and you're like, okay, crap, I know I have to do sine and cosine here. I know I'm going to have some of that. So make yourself on the test, make it first. Do a unit circle, make it. Okay? Just go through and do that, and then you have your values. Does that make sense?
Yes.
Okay, so that should be helpful for that. So now, from, okay, where are we at? Sine x pi over 6? Okay. So sine x pi over 6, 0. So it's going to be 1/2 minus sine at 0 is 0. So my answer is just 1/2. All right. I'm going to have to pick up the rest of this later. Okay? Because these ones right here are a little bit more complicated, and I don't want to try and cram it into the time. All right, you guys got your homework. Tomorrow's going to be homework day for you guys. And Monday, I'm going to finish these notes. So you guys have actually gone through 3 of the examples already, so you should be able to do the majority of the notes, or the homework that I sent you. Make sense? Okay.
Can you help me?
Yes.